Hello grade levels. Let's look at this question 4. This is what we're going to work on this lesson. So if this is your first time watching our lessons, please make sure that you hit the subscription button so that you don't miss the next lesson. By joining the family, we'll make sure that you feel at home. So on this question 4, they say that we are given two function, which is f at x, it's a straight line, and g at x, which is your quadratic function. They tell you that the graph intersect at O and P. So I'm just going to highlight that to show that this is my point of intersection. So we don't know the coordinates of P, but we already know that this O will have the coordinates 0 and 0 because this is at the origin. So let's see what we have on the questions, right? Calculate the coordinates of P. What is the coordinates of P? The point of intersection, where the two graphs meet. To calculate the point of intersection for A, you need to take the two equations, equate them. So to find the point of intersection, we need G at X to be equals to F at X. So when you have it like this, you need to go and check what is G at X equals to. This is X squared. And what is F at X equals to. So if we check on the graph, F at X is given as 2x. So we need to equate this to 2x. Then let's solve for x. So the best way to do this, let's move the 2x to the left hand side. So this will give me x squared minus 2x, and this is equated to 0. To solve for x here, let's take out that x as a common factor. So we can write this equation as what? X into x minus 2. Then this is 0. So this is a 0 product property. 0 product property. We can use the 0 factor law to solve for x. We take this first x that is outside the bracket, we equate that guy to 0, or the value of x will be equals to what? Will be equals to 2. Remember that already we know the x coordinate of what? Of O. So this tells you that this x is equal to 0 is for that O, because the x there is 0. This x, it will be the x coordinate of P. This will be 2. So to find the corresponding y value, what you need to do, you're going to take one of these equations. So I'm just going to take G at x. We know that G at x is y, it's equal to x squared. Where there's x, we substitute that 2 to find what? The corresponding y value of P. So this will be 2 squared, it's equals to 4. So therefore the corresponding y value of P, it's for the coordinates of P becomes 2 and positive 4. And that's it for this lesson, for this question. That's it for this question. So let's substitute the value of P there. So this will be 4, and I'm happy with that. So look at the next question. By using the graphs, we need to answer the following question. Look at this graph and tell us what is the domain of G at x. So G at x, if you look at the graph of G, this is my graph of G. That graph is a quadratic equation. So it takes all the positive and all the negative x values. So as you can see, it takes all this positive, all this negative values, and it also takes all those positive values. So the domain, its x, must be an element of real numbers, and you just have to give it like that, and you're definitely gonna get that 1 mark. So the next question says, determine the values of x for which x squared is greater than 2x. So I'm just going to put this in a simplest way that it will be easy for me to understand this question. I know that x squared is my g at x. So the question is asking, where is g at x greater than? So where is g at x greater than 2x? That's f at x. So where is g at x greater than f at x? Right. Let's go on the graph and try to see where it's f at x greater than where is g at x greater than f at x. So look at this. When you see this type of question, they are asking, where is g above what? Above f. Where is g above f? You go to your point of intersection. This is my point of intersection. This is also my point of intersection. You're going to look, where is g above? So can you look at this? Go in that side. The graph of g, it's above that f. It's above. And then from this point, go in that side. The graph of g, it's above that. So it's above from this x coordinate going in that direction. So x must be less than 0. You're going to say x must be less than that x coordinate of what? Of the point of intersection. Then you do the same. It takes from this point going in that direction. So or the value of x must be greater than that x value of the point of intersection. So this will be greater than 2. So the answer for this, x must be less than 0 or x must be greater than 2. That's how you answer this one. X must be less than 0 or the value of x must be greater than 2. And that's it for this one. So now, for which values of x? It's g at x less than 0. When we say g at x less than 0, we are asking, let me quickly explain this. G at x less than 0, this means that where is g at x? Where is g below the x axis? Because they are asking you where it's y negative. Does g have the negative y values? No. The graph of g is just concave up and it tends at 0. So we don't have any negative y values. This tells you that there's no x values. So the answer for this one, no x values. There's no x values where g at x is negative. There's no x values where g at x is below the x-axis. So this tells you that g only takes all the positive y-axis. There's no negative. So there's no x value that has what? Negative y value. All of the x value will contain positive y values, because look at how the graph looks like. I hope that was an easy one, Magnet. Now the last one, determine the equation of h at x. This is f at x. This is easy, né? Don't stress about that. Just take these 2 marks and say f at x. What is your f at x? It's 2x. So your f at x, it's 2 what? 2x. So to work on this, you're just gonna say my h at x it's equals to f at x, it's 2x, then you add 4. This is the new graph that we formed of h at x. Ladies and gents, that's it for this question. This was an easy question paper. Okay, grade 11s. Let's look at this question 5. This is functions, exponential functions. So if this is your first time watching our lessons, please make sure that you hit the subscription button so that you don't miss the next lesson. So by joining the family, we'll make sure that you feel at home. So we are given h at x, it's equals to a multiplied by 2 to the power x minus 1 plus q. This is exponential. And the line y is equal to minus c is an asymptote. What I need you to understand is that the asymptote of the exponential function is the value of q. So this q, it's y, it's equals to minus 6. So it's given that this line is negative 6. That's the value of q. And the question say, the first question, write down the value of q. Please don't waste time on that. Q, it's minus 6. So t and p are the x and y intercept of h respectively. So we have this as the y intercept and this as the x intercept. If, okay, the question now says, if the graph passes through this point, so this is my x and this is my y. So my y value is minus 5, 1 over 4. Show that the value of a is 3. So you know what I'm going to do? First thing first, rewrite down that h at x in the form of y is equals to. So to answer number B, first let's write that in the form of y is equals to a multiplied by 2 to the power x minus 1. Then you substitute the value of q at negative 6. So we need to subtract negative 6 there. So now to find the value of a, we need to substitute any point on the graph, and we only have this point here, meaning that where there's x you put minus 1 and where there's y we put minus 1. But let's convert this into, okay, so to convert this, remember, if I have 5 half 1 over 4, we're going to say 5 times 4, that's 20. We multiply those two, the answer that you get, you add that one. So if we change this, this will be 5 times 4, that's 20 plus 1. So this can be written as 21 over 4. But remember, it is negative because this point, the y coordinate is negative. So let's quickly substitute. So we're going to sub in the coordinates minus 1, and remember that we just converted this into negative 21 over 4. Right, so now let's work on this. You need to understand what is your y and what is your x. So this is my x and this will be my y. So on the equation where there's y, we need to substitute minus 21. We're going to say this is minus 21 over 4, and then we equate this to a multiplied by 2 to the power, where there's x we put minus 1, then we have minus 6. So the aim is to isolate this term. Make sure that this term is on each side. So we can write this as negative 21 divided by 4. The 6 comes to the left hand side to be positive 6. Then this is equals to a times 2 to the power negative 2. So let's quickly put that on the calculator and see what do we get on the left hand side. So I'm going to say this is negative 21, which is divided by 4, and we are adding 6. So when we add these two, we get 3 over 4 on the left hand side. So this will be my 3 over 4. We equated this to that. So now remember, this 2 to the power negative 2, we can write this in this form. We can write this using the laws of exponents. If I have x to the power negative n, this is equal to 1 over everything without the negative sign. So this 2 to the power negative 2 will be 1 over everything without the negative sign, which is just 1 over 4. So this will be 1 over 4, it's multiplied by a. Remember the a it's over 1. So we can row multiply. This will give us a over 4. Let's quickly write that down. So this will be a over 4. I think everyone understands where is the a over 4 coming from. So when you have it like that, you can just cross multiply. 3 times 4, that's 12. It's equals to 4a. Divide both sides by 4. Divide both sides by 4. You should get the value of a to be 3. Therefore, the value of a is, the 4 cancels. 4 goes into 12 3 times. Then we've managed to do the proof. So this question 5 had only 2 questions. That was the last question of question 5. Can you see how easy it is for you to master functions? You just have to know the trick here. If the q, you're going to substitute wrong value of q, this affects your number b. And that's it for this question. This is how you solve exponential equations.